Hello and welcome to our second of the probability videos for applied math. I can't stress enough how important it is to review the examples in the notes. But here are two more that will supplement it. The reason being that there's so many different ways of looking at probabilities. So it's important to try questions with dice, to look at questions with cards and games and those kinds of things. So today we'll be talking about dependent events. So we're going to be talking about two things happening still. So the probability of event A happening and event B happening. But in this type of probability, the chance of event B happening is dependent on the actual first event occurring. So this differentiates it. And you'll see when we look at the examples. Earlier we talked about what is the chance of the Winnipeg Blue Bombers winning a game and the chance of snow. Well, maybe the chance of snow might increase our chances of winning because we're good at playing in the snow. Whereas snow wouldn't affect the Winnipeg Jets' chance because they play inside. And then after we look at one dependent example, we'll look at Bayes' formula. So Bayes is just a rearrangement of the dependent where we're solving for B given A. So there's this straight line, and just be careful as you're looking through the notes. This is not a divide sign. It's literally just a vertical line, and you would read it as given. So that's B given A. B given that A has occurred. So let's take a look at our first example. So you've got a teacher, and the teacher's got all these wonderful markers, and they're going to be pulling out two markers from this selection. So what's the chance that both of those markers are going to be green? So for our formula, we're going to be looking at event A being the first one is green, and event B being the second one is green. So the word both, even though it doesn't have and in it, we can infer that there's an and in this question. Green and green make both of them green. So what's the chance right now of selecting green from this pile? At this time, there's 2 green out of the 8 that are present for markers. So we're going to take out that first green and put it aside. And then we're going to ask for the second event. So what is the chance of green, the second one being green, given that the first one is green? So this is what we're looking for. The probability that the second one is green, there's only 1 green left out of the 7 altogether, because we have to assume that the very first marker was in fact green. So when we multiply straight across, we'll get 2 over 56. And then we can reduce that. We can make that into a fraction, or into a decimal rather. So you might want to say, 3.5 or 3.6% of the time you'll both get green. So that's a sample question for dependent, where the outcome of the first event determines the probability of the second event happening. Now let's look at one of those conditional probabilities, or the ones that use Bayes' formula. So, and I just want to point out some sort of keywords, some things that are sort of red flags for us. Here we're going to be looking for the chance of ordering fries given that I have ordered a hamburger. So the given part is what we're looking for. So we're saying, what's the probability I'm ordering fries given that I've ordered a hamburger already? So for base formula, we're going to put on top the probability of ordering a hamburger and fries. Hopefully they're telling us that in the question somewhere. And on the bottom, we're going to use the probability of just ordering that hamburger. So that's sort of how our formula works, is we put the and on top and then the initial single event on the bottom. And then this is a divide. So looking at the question, we're just going to take a look through. Do we have the chance of getting a hamburger and fries? So here we see the word and, hamburger and fries. So we could put 45% on top, and you want to be showing that as a decimal. And the chance of getting a hamburger is at the bottom. So the question is, what's the chance that I'm ordering fries given that I've already ordered a hamburger? And it's probably pretty high, because as soon as I get that hamburger, then I'm going to want those fries to go along with it. So if we do that division, it's 0.90. So 90% of the time I'm getting fries given that I've ordered a hamburger already.